Hello everyone, this is me, Amna Malik, and the topic I'm going to present today is effect of expectations on perception of dynamic material properties. So if we talk about object and material recognition, we know that our visual system plays a very important role, and we interact with a number of objects in our daily lives, and based on this daily life interactions, our brain learns to make associations between what an object looks like, what properties does it possess, and what material it is made of. So for instance, we encounter an object. Just by looking at it, we are not only able to tell that it's wine glass, we are also able to tell what material it is made of and what properties does it possess. So there are physical regularities in the world, and based on these physical regularities, our brain learns these associations and store them as prior expectations. And when we encounter an object, these prior expectations are combined with the incoming visual information, and it influences our perception. Then coming to the background, there are numerous studies showing that expectations facilitate the perceptual decisions and it affects the low-level processes. There was a similar study in 2019 by L.A. et al. Where they asked the participants to rate the mechanical properties of objects falling on the ground. And they found out that for the surprising condition, the reaction times were slightly higher. What we wanted to do different was that we wanted to target the perceptual decisions reflecting the low-level processes and not contaminated by high-level processes. So we asked a relatively simpler question, which I'll be explaining later on. So our research question was, do expectations affect the perception of material properties in dynamic scenes and perceptual decisions? Our stimuli consisted of novel computer animations of 6 objects falling on the ground. 3 of them were breaking objects, including a pot, a teacup, and a glass, and 3 of them were non-breaking objects. Now, each object had 2 conditions. The first one is expected conditions, in which the object hits the ground and behaves as expected. For example, here you can see the breaking ones shatter as soon as they hit the ground, and non-breaking ones act rigidly. In the unexpected conditions, we manipulated the animations in such a way they hit the ground and they violate the expectations of participants. So you can see the breaking objects gravel as soon as they hit the ground instead of shattering, and the non-breaking objects wobble instead of acting rigidly. We recruited 12 participants, and each participant was presented with 6 of these objects, all of these objects, and the trials were randomized, and the first 5 trials were always the expected ones, followed by a surprising. So we instructed the participants to answer to the question, did it break, as soon as the object hits the ground after the animation starts. And we recorded their reaction times as the time from the impact frame to the time of their response, that is key press. So here are the results. So we found a significant difference between the reaction times of the surprising stimuli and the expected stimuli. And so you see that these dark blue bars indicate the reaction times of the surprising stimuli, and light blue bars indicate the reaction times of expected stimuli, mean reaction times. So there was a significant difference, and participants took longer to respond to the surprising stimuli as compared to the expected one. So based on these findings, we concluded that expectations do influence the perception of material properties in a dynamic scene, and based on the prior life experiences, individuals have long-held expectations about the future states of objects, and these expectations are reflected in the delayed perceptual decisions when these expectations are violated. So that's it. If you have any questions, you can post them below in the comment section, and thank you very much for listening.